Hey there, everybody. Welcome back to Frontier, Michigan. Jeff here, and today we are going to do a bit of a technical talk of the VQ38. Not quite a deep dive because, unfortunately, while I do have a VQ38, it's not on an engine stand, and I don't feel like ripping my daily driver engine out of the truck just to tear it down and give some technical data and all that about the vehicle, the engine. So we're going to do a little bit of a technical talk. I've done some research as much as I could find on this engine, and there's surprisingly not as much information on the VQ38 as you would assume there would be. You know, it's a VQ, you would expect it to be a ton of information. But surprisingly, there just really isn't on the VQ38DD. Now, before we, get into it, I'm going to tell you guys and be upfront what my mechanical background is so that you know that I'm not just some random YouTuber, just some random Joe or whatever talking about an engine. From 2010 to 2016, the end of 2016, I was a military mechanic. Worked on all sorts of diesel stuff. Anything that was wheeled was basically my realm. I was a wheeled vehicle mechanic. I was a 91 Bravo. Feel free to look up what a 91 Bravo is, and it'll tell you, unless the MOSs have changed, which I don't think they did, a 91 Bravo is a wheeled vehicle mechanic in the military, Army specific. After my service in the military as a military mechanic, I went on to work for Roush Industries for a few years, from 2017 to 2019, right before COVID hit. And there, I was a prototype technician, specifically working in Roush's TASI group. TASI stands for Thermal Aerosystems Engineering. There, we basically built cars. We've taken apart and equipped, Ford products, GM stuff, Mercedes, Audi, German stuff, whatever Ford was competing against at that time and trying to develop a vehicle for. Now, unfortunately, I can't get into specifics of what exactly I worked on, at least technical details. But all I could say as far as that, pretty much every Ford you see on the road since 2020, with the exception of the S650 and the new Rangers, I've essentially worked on before those went into production. My job at Roush in the TASI group was to build the vehicles, the Ford test vehicles, and sometimes they would come in as just a blank shell, and me and our team, whoever I was working with, would work on these cars and build them into a functioning driving vehicle. Sometimes bare shell to test car, or sometimes we would get competitor vehicles in where we had to take them apart, equip thermocouples on there so we can measure temperature at various points on the vehicle, engine, whatever, you name it. We've instrumented it out. And we would then take these vehicles to the dyno cell. This is a climate controlled dyno cell that can essentially simulate whatever weather conditions you could think of. They could generate hurricane force winds. It could generate heavy rains. You could generate even snow in sub-zero temperatures. And when I say sub-zero, I mean, below 32 degrees or 0 degrees Celsius. So you get it pretty cold and generate some snow in there. And you could generate blizzard conditions. You could generate desert conditions with heat. I think the test chamber can get up to 120 degrees in there if they wanted to. So we could test vehicles, all sorts of conditions, and they could simulate even towing and putting a load on a vehicle with the dyno. They could put more load on the dyno which would then in turn load the vehicle up to simulate the high stress of towing a vehicle, which, as you know, when you tow, you generate more heat. So our job was to basically collect data on not only Ford products but competition to see how things with thermal management can be improved, to see what the competition is doing. Maybe they're doing something better. So that was what our role was at Roush in the Taji group. Now, back to the VQ38, because I don't want to drag this out and make it all about me, which there's not much to talk about me anyway, so, you know, ask away, I'm an open book, I'll tell you. So anyway, let me grab my notes here. And yes, I really did just pull these out of my back pocket. But no. This was a few hours worth of searching around. And like I said and started the video with, there's simply not a lot of information out here on this engine. So, we know it's the VQ38. It's based on Nissan's VQ architecture, which goes back to the early 90s when the VQ first came out. And it's been improved upon over the years. So it is absolutely 100% a proven design. And the VQ38 in particular, if you see me crossing stuff off, I'm hitting my notes. I have everything bullet pointed on here. This engine was manufactured in the Deckard engine plant in Smyrna, Tennessee. So it is a US built engine. It is the DD variant. So you got the VQ, which is the family. The 3.8 is the displacement. The DD, the first D, is for dual overhead cam. The second D is direct injection. That's how they do it. Just like on a DE, it was dual overhead cam, port injection. Or something like a VQ38DD. Yes, that does exist. Not in the US market though. That was a VQ30, being that it's a 3-liter. D, dual overhead cam. E, port injection. TT, which is twin turbo, versus just, you know, DET, say like an SR20 DET. So that explains the nomenclature of the engine itself. The VQ, like all VQs in the VQ family, uses a cast aluminum block and cast aluminum heads that are then milled down to spec. So it's a lightweight engine. I believe the engine and heads as dressed is somewhere around like 350 pounds. Don't quote me on that, because again, that's information that is very hard to find. But based on past VQs where the weight is known, and this is a larger displacement, 350 pounds for a dressed engine wet sounds about correct. That is an estimate. It is a 6-cylinder V configuration with a 60-degree V angle. The V angle is the split, or the width of the V itself. So between heads, between left and right, you have 60 degrees of space in that V. It's got 4 valves per cylinder, dual overhead cam. Displaces 3.8 liters, or if you're, say, overseas, that's 3,799 centimeters squared. Or if you're like me, an American, it's 231.8 cubic inches. It features a 95.5 millimeter, which is a 3.76 inch bore. And it has a 88.4 millimeter, or a 3.48 inch stroke. Which, funny enough, that exact bore and stroke is shared with the Nissan R35's VR38. And the other thing that is shared among pretty much all of modern Nissan V6s is the sequential firing order. So oftentimes you'll find a firing order that skips numbers as it goes from bank to bank, where you have maybe like 1, 6, 2, 4, 3, 5, something like that. Nissan V6s run sequentially in their firing order. So you have literally 1, 2, 3, 4, 5, 6 in your firing order. The engine is a 11-to-1 compression ratio. So it's on the upper end. Well, I wouldn't say upper end. It is higher than a typical naturally aspirated engine would be that you would find commonly around the U.S., which most engines here in the U.S. tend to run between 10 to 10.5 or between 9 and 10 if it's turboed or supercharged. So there's not too many engines here in the U.S. that are 11 or higher. For example, Toyota's 3.5 is 11.5-to-1, or say the Mustang Voodoo 5.2 is 12-to-1 compression. It's kind of up there. And you can get even higher, like say Mazda Skyactiv runs like 14-to-1 compression. So it's up there. So power figures. How much power does the VQ38 produce? It produces 310 horsepower at 6,400 RPM. That gives you a specific output of 81.5 horsepower per liter. I throw that number out there because I know some people are interested in those things. They want to know specific output. So for your numbers, guys, the VQ38 produces 81.5 horsepower per liter. It also makes 281 pound-feet of torque. To convert that into European, that is 381 newton meters of torque at 4,400 RPM. So you do have to get it up into the mid-range in order to really take advantage of the torque band. But there are things you could do to fix that. You could tune, intake exhaust, intake spacer, or just throw boost at it. Now, some of the information that is somewhat vague, but does apply to every VQ and VR since the mid-2000s. I did find some promotional information that Nissan had around like 2006 about the new generation of VQs, and they mentioned the use of low friction piston rings. I know some people don't like the idea of a low friction piston ring because they tend to be thinner and not as rigid of a ring. It's done for efficiency's sake because a low friction piston ring is in its name, lower friction. Not no friction, but lower friction than a standard ring. And because it uses low friction piston rings, they also use plasma sprayed cylinder bores. So there's no sleeves in a VQ, at least the modern VQs. So what they do instead, they plasma spray a very, very thin iron coating in the block. And it's not just iron, it's an alloy, but it's an iron-based alloy, which gives scratch resistance because aluminum is soft. So you have to coat it with something that's much harder. So they spray an iron-based liner in there to the thickness of maybe a few thousandths. So it's incredibly thin. I know some people might have issue with that because some of the Coyotes, the 5 liters from Ford, have had issues with the cylinder liner coming apart because they also use a plasma sprayed liner. But Nissan's been doing it for a while. There really hasn't been any issues reported of engines failing because the liner has come apart. So if you're worried about the plasma sprayed liner being an issue, it is absolutely not in the case of the VQ. So I'm going to cross those off my notes. Oh, and being that it shares the same bore and stroke, here's an idea, food for thought. Being that it shares the same exact bore and stroke as the VR38 from the GTR, it is possible to use at least the forged pistons from a VR38. So you could get either the factory forged pistons, or you could upgrade those and get any sort of aftermarket forged piston. The VQ uses a internally balanced steel crank. So the crank itself is strong. The VR uses a internally balanced steel crank, and they can make absurd amounts of power. So that's all of what I could personally find on the VQ38. Now this next section is what Z1 Motorsports has discovered when they first got their hands on a VQ38. Because unfortunately I don't have a second engine that I could put on a stand and tear down and make comparisons that way. So going off of what Z1 Motorsports has found, and this is from a Facebook post that Z1 has made back in 2020, the VQ38 is 90% new compared to the outgoing VQ40DD. So while the general layout of the engine is identical to the VQ40, the components are 90% new. Not necessarily a bad thing, and we'll get into that part later. And like pretty much all modern VQs, it uses an open deck design. So if you take the heads off and you look at the water jackets, there's no support around the cylinders. You literally have open jackets around the cylinders. So it's open deck, internally balanced crank like the VQ35 and 37s. Where the VQ38 starts to differ from a normal traditional VQ is that instead of the oil pump being driven off of the crankshaft directly, it uses a chain driven oil pump, not a belt. It's not a Ford. It uses a chain to drive the oil pump instead, and they use a low friction variable displacement pump similar to the VR38. And the variable displacement, essentially you have your rotors inside your oil pump. It's not really rotors per se, but the part that actually spins, and it spins on an eccentric shaft, kind of like a rotary in a way, but instead of being Dorito shaped, it's round. And on there are vanes. They're spring loaded, kind of like the apex seals on a rotary, and essentially they change how far out they extend. So the more RPM you throw at it, the further these vanes extend, and it grabs more oil to pump through the engine. At lower speeds, it doesn't pump as much oil. So it's speed dependent on how much oil flows. Kind of like all oil pumps are, because I mean, the faster you spin a pump, the more it's going to push. But the way this does it is you basically get max oil pressure, and it alters how much it's pumping. So instead of changing pressure, it's changing how much is flowing, which is kind of interesting. But it is a similar oil pump to the VR38, and to my knowledge, I have not heard of anybody having oil pump failures. Not to say that it doesn't or has never happened, it's just uncommon. So as far as oil pump failures go, you do not have to worry about that with the VQ38. The variable timing control of the VQ38 is identical to the VR30s. So it's essentially infinitely controlled variable timing on the intake cam. The intake cam is electronically timed. Then Z1 has found that it is identical to the VR30s. Now, where the VQ38 definitely makes its departure from traditional VQs is that it uses IEMs. An IEM is an integrated exhaust manifold. So for anybody that wants to put headers on a VQ38, unfortunately you cannot. The exhaust manifolds are cast with the cylinder heads themselves. It is what it is. Nissan isn't the only one that does it. GM does it. Stellantis does it. Ford does it. So that is kind of the thing. Now, where an IEM setup would actually be ideal is turbocharging, because you could bolt the turbo straight to the head where it would be the most efficient. But Nissan did not turbo the VQ38. Just food for thought. If you wanted a turbo one, all you gotta do is find some flanges that made up with the heads. And that's assuming you got room over the motor mounts. So it uses IEMs. So, you know how the VQ37VHR has the VVEL system, and it's kind of a hydraulic system that, well, it's not hydraulic on the VQ37. It's electronically controlled, but it's variable valve event lift. It's kind of like VTEC, but not like VTEC, where the engine, based on load and RPM, can alter its cam profile.
What's the problem?
There's no problem making a video.
Oh, making a video? Ah, got ya. I'm just double checking, make sure you're all right.
Nah, I'm good. I do appreciate it, though.
Yep.
Take care.
Yep, you too.
Oh, that's good. You came down to check on me, but not really a need to, and it is what it is. So, okay, so back to where I was. The VVEL system, which is your variable valve event lift system, it effectively alters the cam profile by changing how far the valves open to allow more or less air into the engine as needed. The VQ38 does not use the VVEL system, so it eliminates the issues that were associated with that system in itself. However, it retains the hydraulic cam phasing that was used in the VQ37VHR. So with oil pressure and RPM, it changes the cam phasing that way on the exhaust side. And similarly to the VQ37, it uses a tumble valve in the lower intake, and it's essentially a electronically controlled flap in the lower intake manifold that creates a swirl effect before the air goes into the cylinders. And this improves emissions, it improves efficiency, and it improves power by creating that swirl near the inlet ports. So that's pretty much all of the main information that I could find, or Z1 has found, in regards to the VQ38 in and of itself. Now, let's move on to like recall and TSP information. So the VQ38, it came out in 2020, late in the second gen, the D40 Frontier's life. And since 2020 till now, there has been absolutely 0 recalls tied to the engine itself. There has been recalls related to the 9-speed. Those have been resolved. But as far as the engine itself, the VQ38, 0 recalls. For all the haters out there, 0 recalls. Now, TSBs, which is a technical service bulletin, not a recall. But a TSB is where there is a known issue, and it's on a voluntary basis where you can come in and have said issue corrected if it is present. And TSPs are typically done when there is an issue, but it doesn't quite meet the threshold for a recall. So as far as TSBs are concerned, directly tied to the engine itself, because I know if you go to the NSTSA's website, it'll say powertrain. When they say powertrain, they're talking about things like axle, transmission, because there are TSPs that were out for the 9-speed or for the rear axle or for the CVs with clicking and other issues. That'll be a different video for another day. So, TSPs directly related to the VQ38, 0. So for the haters, once again, 0 TSPs, 0 recalls. And this information is directly taken from the NHTSA, or NHTSA. Does that mean that the VQ38 is absolutely without issues? No. And as with any mass-produced vehicle, there will always be a few bad examples. It happens. If you look on Facebook, the Facebook groups and various forums, you see a lot of negativity, especially in the Facebook groups. Take it for what you will with a grain of salt, because that does not represent the majority. And a lot of those groups, the negativity seems to overshadow the positive sides. And that's with any platform, any engine, any vehicle, it doesn't matter. If it's negative and somebody says it on the internet, it's going to get attention. It is what it is. And nobody wants to hear about, oh, I had one for 2 million miles with no problems. That doesn't get headlines. That doesn't get attention. But as soon as somebody goes on there and says, my engine yeeted a piston into orbit, it's got 300 miles on it, then you're going to get a bunch of other people on there chiming in saying the same thing that may or may not be necessarily true. And this is where I have a problem with something like Consumer Reports. I know a lot of people swear by Consumer Reports. But let's just say there is a reason Consumer Reports started charging people membership fees so that you could post. Because people were going on there and writing whatever they want about a vehicle that's negative, and it hurts the reliability score or the predicted reliability score from Consumer Reports. And the other reason I do not go off of what Consumer Reports says is because any little nitpick, any little complaint, whether it's resolved or just the owner doesn't like it, is aggregated across a brand. So, for example, with the Frontier, Consumer Reports doesn't rate its reliability based on one model. The Frontier's reliability rating is based on Nissan as a whole. So the aggregate you find is as a whole. And, well, Nissan has had a bad image over the years, and it's mainly due to things like CVTs. They were notorious for CVTs going bad at like 60,000 miles or sometimes earlier. Supposedly that's been corrected and really isn't so much an issue anymore, but the damage has been done. But I will say this. Since the year 2020, there have been roughly, at the time of this video, at the time of my research, I added it all up, there have been about 352,039 Frontiers sold with the VQ38 with no recalls, no TSPs issued for the engine. And what that tells me is, other than a few bad examples here and there, because again, mass produced, so you have the tolerances of a mass produced vehicle, they vary, there's inconsistencies, it happens in all brands. But no recalls, no TSPs have been issued for the engine, which proves that its reliability and long service life, which of course is dependent on proper maintenance. You know, you could have the most historically most reliable engine in existence, but if you don't do simple things like check your fluid levels or change your oil when it's needed, it's not going to last. You know, it doesn't so much matter if you beat on it or not. If you don't keep up with the maintenance, it's not going to last. Now, yeah, you could beat on an engine, and as long as you don't exceed its capabilities, you're not doing anything major other than maybe shortening its expected life. But, you know, if something does go bad, Z1 has a long block for less than $1,000. Just throwing that out there. So, you know, you guys let me know what you think down below. I think the VQ38 is going to be a great engine. It so far has proven itself and is continuing to prove itself. And of course, you can go online and read up all so-and-so having this problem, which they're out there. You know, you can go onto any forum and find issues. I remember the 4th Gen Tacomas having transmission problems. In fact, there's a video floating around on YouTube about a 4th Gen Tacoma 8-speed auto where the transmission went bad and it's got like 500 miles on it. So, there's that. Things happen. It's mass produced. There are going to be variables in manufacturing that may or may not hurt its expected lifespan, and it's just the thing of it. And as far as the Toyota's 2.4 turbo, I have heard from an engineer that that engine is designed to go 200,000 miles. And what that tells me is, hey, they expect it to do 200,000 miles with proper maintenance. And then after that, well, we'll see. Now, that engine has been out since 2021, 2022. Comment down below if I'm right on that. And that engine has also, so far, been proving itself. No recalls that I can find there, and no real TSPs I can find there, but I really haven't dug too deep on it. So, this video is starting to get a little long. I'll let you guys go. And like I said, comment down below. We can talk about it. All I ask is be respectful. You know, I don't need criticism and trolls and all that, because that doesn't help anything. But if you want to have a good talk about it, we could have a good talk. Hope to see you guys down below. And I hope to see you guys again on another video. My name is Jeff. This has been an episode of Frontier, Michigan. It's an amazing day, so get on out there, and I'll see you later.